In order to eliminate the parameter of a parametric equation involving trig expressions, we can pretend that the equation, or a single equation, is talking about the parts of a triangle. So for instance, y equals cosine of t in part A here, we can treat as talking about the triangle like so, with an angle of t, considering t is inside the cosine. If this is the case, cosine talks about cosine of t would be equal to adjacent over hypotenuse. Well, y isn't a fraction, but we can make it one. Let's make it y over 1. Adjacent over hypotenuse then would be y here at the adjacent and hypotenuse of 1. Knowing this, we can find our third side here just by using Pythagorean theorem. That is, this would be the, if we call this side, let's say, k, then k squared equals, k squared plus y squared equals 1. And we can solve for k just by subtracting the y squared and taking the square root, so k is equal to the square root of 1 minus y squared, which I'll replace it with. Alright, knowing this, then we can create a relationship between x and y just by evaluating sine squared of t. Well, if this is t, sine is opposite over hypotenuse. Then x is equal to, instead of sine squared, we say opposite, square root of 1 minus y squared, over hypotenuse, which is 1. And this term squared. Now notice dividing by 1 doesn't actually do anything, so this is just the square root squared, which is then equal to 1 minus y squared. Then our equation is just x equals 1 minus y squared. I notice that the x is not squared and the y is. That tells us right away that what we're dealing with is a parabola. So we've identified the conic section. The next part is to determine the types of properties that we have to identify. So a parabola has a vertex, a focus, and a directrix. Knowing this, let's put this into standard form. That way we can identify some characteristics. So 1 minus y squared can actually be factored. We can factor this as 1 minus y times 1 plus y, but that's not too helpful to us because y needs to be squared. So instead what we're going to do is move the 1 over and have x minus 1 equals negative y squared. Then I want to get rid of this negative here, so I'll say y squared, I'm also flipping the sides here, equals negative x minus 1. And I can see here that this is in standard form now. We just have to identify the p. I notice that there's no p here, there's no 4 either, because recall the standard form for a parabola is y minus k squared equals 4p x minus h, possibly with the x and the y switched. There's no 4 there. So what we can do is factor out the 4. So even though there is no 4, we'll factor out a 4, and then say what's left, which would be negative 1/4. So we can treat this as negative 1. When we divide and multiply by 4, we get this right here, times x minus 1. And now we're in standard form definitely, where we can identify our p and the other values. The vertex is at h and k, which I notice that k is equal to 0, y isn't being subtracted by anything, but the h is being subtracted, so our vertex is at 1, 0. Our focus depends on p, so p is negative 1/4, and notice that this parabola has the y being squared. That means our parabola either goes left or right. And since p is negative, it's going to go to the left. In other words, in the negative direction. So let's hold on to just the left side with the vertex at 1, 0. That means that the focus also goes to the left of the vertex. So the focus is equal to 1, and then we have to move it to the left, so minus 1/4. Then there's still the 0 there. 1 minus 1/4 is just 3/4. Finally, the directrix can be found the opposite direction from the vertex as the focus. So the focus went to the left, we'll just go to the right. And the directrix is a line. Notice that since this is vertical, it's going to be x equals. And we take the x value, 1, and we add 1/4 instead of subtracting. So 1 plus 1/4, which is just the same thing as 5/4. So x is equal to 5/4. Using this information, we can create a graph. I have a point at 1, 0. Let's call that here. And a focus at 3/4, 0. So right here. And a directrix at 5/4, 0. Or excuse me, just x equals 5/4. So our parabola should look something like that. I also noticed that the question asks about focal diameter. Focal diameter is another property of parabolas. That is, focal diameter is always equal to 4p. And here we have 4p. 4p, p is negative 1/4. Focal diameter is always positive, it's a distance. So focal diameter is just 1 here. And that distance is the distance vertically, in this case, across the focus.